If we take two radii and put them together, they actually sweep out what's called a sector. If you take a look at this circle here, circle centered at A, then what you see here, we actually have two sectors. We've got this purple sector, which is this region right here, and we've got this teal sector, which is this other region here. And so it turns out that we can actually study these sectors, which you can see are just part of the entire circle. So, for example, if you want to find the area of a sector, obviously it's going to be some appropriate fraction of the area of the circle. Now, the area of the circle, of course, we know is pi r squared. So how do we figure out the appropriate fraction? Well, that's given by this neat formula. Pi r squared, that gives the area of the whole circle, and this is the fraction that's required, which is, we know that the total angle around is 360, and so all we need to know is the measure, either the measure of the central angle, or equivalently, the measure of the arc, and then we can actually figure out what the area is, because that will give us the fraction of the area that we want. So, for example, here, suppose that we want to find the purple area of the area of the purple sector. So that would be the area of the purple sector, DAE. How would we do that? Well, we would just find out what fraction of the area we should consider. It's not really a big deal. So if you want to find the area of sector DAE purple, that would equal pi r squared. And so here we see that r is 5, so that's going to be 25. And then I'm going to multiply that by the appropriate fraction. Well, I'm given that the measure of this arc, the measure of this arc is 150 degrees, so I put that over 360 degrees. And so what do I get? In fact, let me put this piece of paper here so you can see this a little bit better. And so what I see here is, well, you can actually reduce this down a little bit. I could simplify that a little teeny bit. Pi times 25, I can put 15 over 36. And if you actually compute this on a calculator, you'd see 32.7. And what are the units? Well, this represents area, so it's inches, but it's inches squared. Inches squared. So you can see how you can use this formula, which I think makes a lot of sense, in finding the area of sectors. It's literally the area of the circle multiplied by the appropriate fraction of the circle that you actually are. No big deal.